In this video, we will discuss how to solve two-step equations using inverse operations, in particular the inverse order of operations. The first thing to remember is our regular order of operations. You may recall GEMDAS, hopefully. And when we do GEMDAS, it's grouping, exponents, multiplication, division, addition, and subtraction. Okay? So that is our regular order of operations. That's when we are simplifying expressions. For example, 3 plus 2 times 4 minus 7, right? I would do the grouping symbol, the parentheses first. Then I would multiply, and then I would add, right? Because I have grouping, and then I have multiplication, then I have addition. Okay? But there are equations that we're going to solve, and our goal when solving an equation is to isolate x. Okay, that's always our goal, is to isolate x, or whatever the variable is. To do that, I'm going to remove all of the other operations and numbers around x. So I'm going to use the inverse operations, or opposite operations, compared to what we normally do in simplifying problems. So, first thing to remember is that the opposite of addition is subtraction. These are our inverse operations of each other. The opposite of multiplication is division. Later on in the 8th grade curriculum, we will talk about the opposite of an exponent being a square root. But you don't necessarily need to know that right this moment. Simply remember that we have adding and subtracting our opposites and multiplying and dividing our opposites. Along with knowing what those opposite operations are is remembering what order we use them in. So the inverse operations means I'm going to use the opposite order. So instead of GEMDAS, I'm going to go with SADMAG. A little more depressing, sorry. But we are going to use subtraction first, then addition, or these really together, right? Remember, these are kind of a partner package deal. And then I have division, multiplication. Again, kind of a package deal. And I have any exponents to get rid of, and then I have parentheses, or a fraction bar that's dividing an entire denominator by an entire numerator, etc. Any grouping symbols go last when it comes to simplifying and solving. Okay? Our first example is going to be a two-step equation. Now, the steps that I lead you through, I do want to see the inverse operations on your paper. Any other tips and tricks I give you are not mandatory, but strongly encouraged because they are very helpful when it comes to organizing your thoughts and will become very crucial when we get to variables on both sides, distributing, combining like terms, all of that fun stuff. So, I am going to start by what I say is draw walls. You're going to draw a line through the equal sign so I can clearly see the two sides of the equation. Again, only have one variable right now, so it's fairly easy to see what's going on. But just in case, and for future habit building, I recommend you put that line through the equal sign and give yourself some space to show some work on either side, okay? So I'm going to start with my inverse operations. I see that I have multiplication here, because remember, anytime I have a number directly next to a variable, that's multiplying it. And I have an addition sign over here. So I have two operations. This is the two-step equation. So I'm going to do two things to isolate x completely. Now, I need to divide by 3, and I need to subtract by 7 to find x by itself. But order matters. It always matters, okay? So I have SADMAG over here. So am I going to undo the addition or the multiplication first? Think about it for a moment. Pause the video if you need to. I am going to undo the addition first with subtraction, because addition and subtraction come before multiplication and division. So I'm going to subtract 7, and if I do it to one side, I got to do it to the other side, because remember, when we're solving equations, I want them to be equal So if I do something to one side of the equation and I don't do the same thing to the other side, now I've changed this from an equal situation to an inequality. And I don't want to change the value of one of the sides completely. I want to keep it balanced, okay? Now I didn't do anything with 3x, so I'm going to just bring that down to the next step. The 7 minus 7 should cancel out. That's the reason why we use the same number, so they can cancel out, okay? And then 43 minus 7, so I have 3 minus 7, I do need to borrow. And then I have 13 minus 7 is 6, and 3 minus nothing is 3. And then continuing on, now I'm going to get rid of this multiplication here, right? And I'm going to do the inverse, which is division by 3. If I do it to one side, do it to the other. Now 3 divided by 3 gives me just x, which is what I want. I want to have x isolated. X is isolated when the coefficient is 1 or there's nothing written there, which means it's 1. And 36 divided by 3. So 6 divided by 3 is 2. 3 divided by 3 is 1. X is equal to 12. Now I can check that this is true by just plugging 12 in. And 3 times 12 is 36 plus 7 equals 43, which means this is correct. I'm going to continue again putting that line through my equal sign so I can organize myself. Here's the thing with a problem like this. Everyone sees fractions and goes, oh no, what am I doing? And believe it or not, this is easier than the previous example, as long as you think about it as a division problem. Remember, this fraction bar is another way of saying divide, okay? And 1/7 is being multiplied times x, right? So I could write 1/7 times x over 1. In other words, x over 7 minus 6 is equal to this 14. If it is easier for you to recognize that this is division by actually multiplying that variable times the fraction in front of it, please feel free to do so. So again, I'm going to use my SADMAG, right? I do have some subtraction that I need to remove. I'm going to do the opposite, which is addition. If I do it to one side, I do it to the other. I end up with 20 and x over 7 because negative 6, positive 6 cancels out. Now the inverse of this division is multiplication. So I am going to multiply x times 7. This gives me 7x over 7, which of course simplifies out. But if I multiply by 7 over here, I have to do the same thing on the other side. 7 times 20 is 140. And x times 7 divided by x is just x. Therefore, my final answer is 140 is equal to x, or x equals 140. This problem is a slightly tricky one because at first glance, it looks like a one-step equation, right? We have one sign, we have a variable, and we have another number on one side of the equal sign, okay? But this is in fact a two-step equation. If you look closely, this 13 is positive. There's nothing in front of it to suggest that it is negative. It is a plus 13. The negative, or the minus sign, is with x. So I could rewrite this using my keep, change, or my additive inverse, right? 13 plus negative x. And then I can rewrite it from there to show that negative x plus 13. Now this is just like any other two-step equation. I can also, if you wish, include a 1 as a coefficient there, a negative 1x, if that helps you see it a little more clearly. So I have negative 12 equals negative 1x plus 13. So I have two operations. I have multiplication and I have addition here. So I'm going to get rid of addition first because SADMAG gets rid of subtraction and addition before multiplication division. If I subtract 13 from one side, I have to subtract 13 from the other side. So because I have two negatives being combined over here on the left side, I am essentially adding those. I end up with negative 25. And I still have negative x here. Now remember, if x is not positive 1 for a coefficient, it is not isolated. So I am not finished until I remove that negative. And I can actually do that in two different ways. That's one of the nice things about negative signs. So I can get rid of this negative 1 by dividing by -1 on both sides, right? Because -1 divided by -1 gives me positive 1x. Or I can say -1x times -1, right? -1 times -1. Negative times a negative becomes positive x. And if I multiply this times -1, it also gives me positive 25. So either way, x should equal positive 25. Alright, write these problems down, give them a shot on your paper, and make sure you show Mrs. Jackson before you move on. Pause the video now. One last example with some pretty wild rational numbers here. So I'm going to start off by again drawing my wall. And I have subtraction and I have multiplication here. So side mag tells me I am going to remove the subtraction first by adding. I'm going to add 3 4/10 to both sides, but since it's a decimal being added to an integer, I'm going to make sure I line up my decimals. Okay. Now -3 4/10 plus 3 4/10 is going to cancel out, which we want it to, right? Because our goal is to get this x by itself. So I'm going to first get 1/3 x by itself. From there, I notice that I have a subtraction sign, so I'm going to do opposite operations because one is negative and one is positive. I'm going to have to borrow from this 5. And 10 minus 4 gives me 6. 4 minus 3 gives me 1. The negative number is larger, so I'm going to keep that negative. Now, my last step here is to isolate the x, which means I need to get rid of this 1/3. Thinking back to an earlier problem, remember 1 times x and 3 times the imaginary 1 on the bottom gives me x over 3, as well as 1/3 x. So what I'm going to do to isolate x is I'm going to multiply by 3 on both sides. Okay? So I'm going to go times 3. Now, this should cancel everything out so that x is completely alone, and it is. 3 times 6 gives me 18. 3 times 1 is 3, plus 1 is 4. It's a negative because it's a negative times a positive. I have 1 decimal place, so I'll move it over 1 time there. -4 and 8/10 gives you your final example answer.